Okay, so this problem says restrict the domain, then find the inverse of, and it gives us this function. We know it's a quadratic function, and we know where the vertex is at. The vertex is at 2, -3. And so let's look at what the graph looks like. So let me scroll up a little bit. So it's a right side up parabola, the basic shape, but 2, -3. So my vertex is down here. And I'm getting a parabola that looks like this. And so how are we going to restrict it? Well, they don't really tell us anything. Sometimes they will. They'll tell you how to restrict it. But generally, I would take the right-hand side of the parabola as opposed to the left-hand side. So you want to think about where is that axis of symmetry. And so we're just going to take x values greater than 2. So we're going to restrict this to say x is greater than or equal to 2. And then now that gives us a one-to-one function because we're going to take this part. Well, there goes my parabola again. We're just going to be having this side. Now you might be saying a couple things. One, could I restrict it to the other side? We did that, in the previous problem. Yes, you could do that. Another thing you might be wondering is, well, how about if I restrict it so, x is just greater than 4, say, or some other number? No, we can't do that. We have to be true to the function. And so half a parabola, that's okay. But less than that, that's not really okay. All right. Now let's talk a little bit about the domain and range here. Go back to my orange pen. The domain then of f is going to be from 2 to infinity. And the range for f is going to be, if you look at it, it's going to be from -3 to infinity, right? This is a right side up parabola, and that's what it's doing. Okay, now let's go to find the inverse. So we're going to say y equals x minus 2 squared minus 3. We're going to switch x and y. We're going to add the 3. We're going to take the square root of both sides. We're going to have to decide which sign we want, the plus or the minus. We can go ahead and add the 2 over. Now when you write it this way, you want to make sure you don't put that 2 under the radical. And then we're going to think about, well, remember, if my range for the original function is -3 to infinity, then my domain for f inverse has to be -3 to infinity. And then the range for the inverse has to be 2 to infinity. So I need outputs. I need the y to be bigger than 2. And so that's going to give me the positive case then, which you probably already expected, but oh, and I want to write this with the inverse notation. Well, I'll just do it underneath. Now, the great thing about what we've already done with our toolkit functions and our transformations is we know what this looks like. We know it's a square root curve, and it's going to be shifted 3 to the left and up 2. So shift 3 left and up 2. Okay, so our normal, I'll just try to dot it in here. Our normal one kind of looks something like that. But now we're going to go 3 to the left, 1, 2, 3, and up 2. So we're going to have a point there, we'll have a point there, 1, 2, 3, 4, and a point there. And so it'll be going off that way. And hopefully that looks symmetric about the y equals x line. I'm not going to get the whole line in, but should be symmetric about that green line. I don't know if you can see it. Yeah. But if you fold it on that dotted line, the orange points should line up with the black points. It's a little off to me, but I think maybe I didn't count right. 3 left, up 2. It's probably just my bad drawing. Okay, so we restricted it. We decided to go with the right-hand side of the parabola, and then we're able to get the inverse, and then we can graph both of them on the same graph.